Okay, so today we're going to look at the following problem, which is actually a fun puzzle of numeral system. And here is what we're trying to do. Assume that we have a 3-digit number ABC, which is actually in base 7. And we actually want to find out this number ABC in base 7, of course, such that if we reverse the order of the digits, so in other words, if we write as CBA in particularly base 9, we will actually get the same value. So you can pause the video and try yourself first. And this actually requires a little bit of the fundamental knowledge in number theory. So you can try to figure it out and see if you get the same answer as I do. Are you ready? Here we go. So first, since A, B, and C are just digits of the expression, and they're all digits in base 7, we know that A, B, and C must be one of the following digits. It will be 0, 1, 2, all the way up to 6. And again, we cannot have these digits be 7 or higher because otherwise it will not be in the expression in base 7. Moreover, since we are assuming that this is a 3-digit number, we need to assume that the first digit or the far left digit cannot be equal to 0. So in this case, on the left hand side, we will have A cannot be 0. And on the right hand side, we have C cannot be 0 either. So here is the second condition that we have. Last, if we think carefully, if we have the expression in base 7, the far left digit, which is similar to the leading coefficients if you're thinking in algebra, has to be strictly bigger than the leading coefficient or the far left digits that is in base 9. Otherwise, if they are the same, we will end up with the value on the left hand side is equal to the right hand side, which gives us a contradiction unless B is equal to 0. And no, it will actually end up with a contradiction even if B is equal to 0, because now if we assume that A is equal to C, we will have 1b1 is equal to 1b1 in 2 different bases, which is not true because by the definition of how the expression would be. So we have A has to be strictly greater than C. So what does that help? What does that do? And how does that help us? Now we're going to use the meaning of what base 7 is. This means the left hand side will be A times 7 squared plus B times 7 to the first power plus C times 7 to the 0th power, which of course if we try to rewrite it, it will just be 49A plus 7B plus C. And that is how the left hand side mean. Then on the right hand side, we will just play the same game. We have C times 9 squared plus B times 9 to the first power plus A times 9 to the 0th power. And if we try to simplify that, we end up with 81C plus 9B plus A. So now we just need to play around with the algebra. And in order to make the calculation nice, we will just try to keep everything in positive values. So I'll keep the A on the left hand side so that we end up with 48A. And then I'll throw everything else to the right hand side. And that will give us 80C plus 2B. Of course, since A, B, and C are one of the digits up here, they are integers, so we can just try to divide everything by 2 and simplify it, which yields 24A equals 40C plus B. How does that help? Well, if we now rearrange the order, we get B is in fact equal to 24A minus 40C. And on the right hand side, we can also try to factor out something. What is the highest common factor? Well, we don't know what A is, we don't know what C is. But between 24 and 40, we know that the highest term that we can factor out, or the biggest factor, will be 8. And if we do that, we will end up with 3A minus 5C. But keep in mind, A and C are both integers, so 3A minus 5C is also an integer. So that means B is not just an integer, it has to be a multiple of 8 because we have 8 times some integer. But now, think of what possible B is. If B is a multiple of 8 or is divisible by 8, the only possible solution will be B is equal to 0. Good. So if B is equal to 0, now as we throw back in here, we see that 3A minus 5C is equal to 0, which gives us 3A is equal to 5C. As both A and C cannot be equal to 0, the only possible solution will be when A is equal to 5 and C is equal to 3. So what is the final answer? The final answer is 503 in base 7. And that is the 3-digit number that we want to find. So now we're going to verify it. So as we claim the answer is 503 in base 7, we need to double check whether it is true. So on the left hand side, we have 503 in base 7, and by the definition, we have 503 meaning 5 times 7 to the second power plus 0 times 7 to the first power plus 3 times 7 to the 0th power. As we simplify it, we have 5 times 49 plus 0 for the middle term plus 3 times 1, which is 3. And that will give us 245 plus 3, which is actually equal to 248 in base 10. Now on the right hand side, as we reverse the order of the digits, we have 305 in base 9. By the meaning of it, we have 3 times 9 to the second power plus 0 times 9 to the first power plus 5 times 9 to the 0th power. And if we simplify it, we have 3 times 81 plus 0 in the middle plus 5 times 1, which is 5. And 3 times 81 is 243 plus 5, which also gives us 248. And therefore, 503 in base 7 is the answer and is the only possible solution for this puzzle. That's it. I hope you all enjoyed this video, and if you do, please don't forget to like so that I know you actually like this kind of idea. And also, if you want to find out more of my other videos, you can subscribe to my channel. And if you don't want to miss any of my new videos, you can turn on the notification as well. If you have any thoughts or comments or ideas, you can actually leave your comments down below. I'll see you guys in the next video.